You may hear someone say, "These temples are too big for farming villages. Agriculture left no trace in Malta." It's a dramatic statement, but it doesn't survive contact with the evidence. Over the last 30 years, archaeologists have assembled an entire toolkit of scientific methods, from microscopes that identify single grains of wheat to chemical signatures inside human bones, and every one of them points to the same conclusion. The Maltese temple people were farmers. If you like these type of videos, may I take this opportunity to remind you to hit the subscribe button and be able to watch more similar stories. Let us begin by looking at the archaeobotany. Picture a charred wheat grain, barely 3 millimeters long, blackened in a hearth 5,000 years ago. Archaeobotanists, trained to recognize crops under the microscope, have recovered thousands of such fragments from Maltese sites. At Tas-Silġ, researchers identified emmer wheat, known as Triticum dicocum, barley, known as Hordeum vulgare, and einkorn, known as Triticum monococcum. These are domesticated cereals, not wild grasses. The finds were first reported in the 1990s and then studied systematically during the ERC Fragsus project carried between 2013 and 2018, led by Professor Caroline Malone at Cambridge. Why does this matter? Charred grains and cereal chaff appear because people harvested, cleaned, and roasted crops. This is cultivation in action, not chance weeds. Let's now look at the diet written in bone. In other words, we look at the isotopes. What did people actually eat? For that, scientists turned to chemistry. In the late 1990s, Michael Richards, Robert Hedges, and Caroline Malone analyzed human bones from the Xagħra Circle. By measuring the ratios of carbon and nitrogen isotopes in bone collagen, they reconstructed long-term diet. The results: these Maltese villagers lived on a diet rich in cereals and domestic animals, with little reliance on marine foods. Later Fragsus studies in the 2010s added more samples, confirming the pattern. In other words, the very chemistry of their bones says, "We are farmers." Another point to look into is the farmer's toolkit. Excavations also turn up the tools of farming. At Ta Ħaġrat, archaeologist Claudia Vella documented flint sickle blades, their edges shiny from cutting stalks of grain. Across sites, excavators find querns and grinding stones, heavy slabs used to crush grain into flour. Alongside, the pottery tells its own story. Huge coarse storage jars, some over half a meter tall, appear in the Tarshine and Gigantea phases. Their size and thickness suggest one main purpose: storing harvest surplus. When you line up sickle blades, querns, and storage jars, you see the full farming cycle, from harvest to grinding to storage. So what does the landscape tell us? To answer this question, we have to look at the pollen traces in soils. Even the environment keeps a record. In 2016, Gambin and colleagues published pollen studies from cores drilled in Burmarrad Valley. Under the microscope, they found cereal pollen grains dating back to the Neolithic, alongside a decline in tree pollen, evidence of woodland clearance. Soils tell a similar story. Fragsus micromorphology studies showed ancient terracing and erosion patterns typical of repeated plowing and cultivation. Together, the landscape itself whispers, fields, not untouched wilderness. So once more we ask the question, how many people could the land support? Fragsus researchers used GIS mapping and crop yield models to estimate Neolithic populations of 5,000 to 10,000 across Malta and Gozo. By modeling arable land, rainfall, and terracing, they showed that small-scale but steady farming was enough to sustain villages, with reserves to spare. The demographic maths works. The temples didn't require more people than the land could feed. So how did farmers move stones weighing 20 tons? Archaeological stratigraphy shows that temples like Gigantea weren't built overnight. They were extended and remodeled across generations. A single construction phase might take years. allowing labor to be spread out. Modern experiments give us the right image to understand. At Stonehenge in the 2000s, Mike Parker Pearson's team moved 40-ton blocks using only ropes, sledges, and wooden rollers. To the eyes of the spectators, this was achieved with teams of under 200 people. Combine that with harvest surpluses stored in jars, and temple construction becomes a seasonal, communal project and not an impossibility. So why do people still say no agriculture? First, preservation is patchy. Malta's thin limestone soils and centuries of antiquarian digs mean many contexts were destroyed before modern sampling. Grain remains don't always survive. Second, selective reading. Popular accounts dwell on the giant stones while ignoring the mundane but decisive evidence. Tiny seeds, glossed sickles, isotope ratios, storage jars. Yet specialists, especially in the Fragsus Temple Landscapes volumes published in 2019, consistently integrate both the monumental and the everyday. Therefore, the verdict lies in the evidence, and this converges from every angle. You have seeds and chaff under the microscope, bone chemistry recording cereal-heavy diets, flint sickles grinding stones in storage jars, pollen cores showing crops in cleared land, population models confirming sustainability, and experiments proving farmers could move stones. Malta's temple builders were not mystery peoples. They were farming communities, managing land and resources with skill and pooling effort to raise monuments across generations. The idea of no agriculture simply falls apart when set against the science. Thanks for watching. If you like this type of videos and would like to support this channel, please do not forget to like and subscribe.
If you enjoyed this, don't forget to like and subscribe for more awesome content.